Good afternoon, this is Ms. Parks, and we're going to be doing section 8.3, which is to find the trig functions of any angle that they give you, okay? And we are going to use the unit circle that's in the previous section, in the 8.2a, where we talked about the unit circle. So again, here we have sine, cosine, and tangent. Sine is y over r, so that's SOHCAHTOA, which is opposite of hypotenuse, because really you're going to be using this right triangle here for the most part that is left over after you do your xy point. Cosine is x over r, adjacent over hypotenuse. Tangent is opposite over adjacent, and again you'll be using this triangle here. And then cosecant, secant, and cotangent are reciprocals of those, and they're just telling you that the denominators can't be 0 or you will get an undefined answer. That's it. All right. So for the first one, they want us to do all 6 trig functions. So sine theta, cosine theta, tangent theta, and then cosecant, secant, and cotangent theta. So we have the point -4, 3. So -4, +3. And we always make the right angle on the x-axis, no matter what. So make the right angle on the x-axis. Next, we will be using this triangle. Okay, so in this triangle, we're going to be using x, y, and r. So x, -4. Y is 3. And r, if you do the Pythagorean theorem here. Now, the triangle really can't have a negative length here, but it's 3 squared plus 4 squared equals r squared, and r is always positive. Always. Okay? So if you work this out, 9 plus 16 equals r squared, 25 equals r squared, so that's 5. The 3, 4, 5 is the most common right triangle, so if you knew that before doing any of the work, then that's fine. Okay? Now, to do sine, cosine, and tangent, you can use this angle here. You always use that angle. You can use SOHCAHTOA if you want. Or this is y over r. So y over r, 3/5. Cosine is x over r. So cosine is -4/5. And remember, for tangent, you could just take that number and then do tangent here. But it's y over x. It's actually slope. So if you think of slope as y over x, you should get -3/4. For the other side, they are just reciprocals. So 5/3, -5/4, and don't put the negative sign on the bottom, please. And then for the last one, it would be -4/3. The other thing I don't want you to do is sometimes people will write cotangent theta equals -4/3. So the negative sign and the equal sign are lined up. Please do not do that. Go ahead and try the next problem. It'll be the same type of work, and don't forget you do need to reduce everything before you write your final answers. Sine theta, cosine theta tangent, and cosecant theta, secant theta, and cotangent theta. And yes, you need to write theta. You can't just write sine, cosine, tangent. All right. So I have 8, -6. So 8, -6. Okay, so x, y, r. So for r, we're going to have a squared plus b squared equals r squared, or x squared plus y squared equals r squared. So r is equal to 10. This is the same exact triangle as we had before. That's a 3, 4, 5. It's just we need to reduce these. So if we reduce these here, it's easier to reduce once than to reduce 6 times. Okay? So you can choose whatever you want to do. Y over r, x over r, y over x. All right? So I'm going to use these numbers. So this is going to be -3/5, 4/5, and -3/4. So it's almost the same. The reason that tangent's the same is because their slopes are the same. So if you were to like extend that out, it would be exactly the same. Cosecant, negative 5/3, cosine, positive 5/4, and cotangent, negative 4/3. So that covers the first two. Next, unit circle. We've already talked about the unit circle. So for the unit circle, x squared plus y squared is equal to 1 because the radius is 1. Okay, so anytime you have x squared and y squared and you add them together, it's going to equal 1. Okay, so the radius is 1. Sine theta in a unit circle is just y. Cosine theta in a unit circle is just x. And tangent theta is still y over x. Okay? All right, so we're going to use a calculator. It says not use a calculator, excuse me. No calculators allowed. To evaluate the 6 Triggs functions of 270. So I'm going to go ahead and go over it so you can kind of see what's going on here. So we have sine. Actually, let's go ahead and put sine of 270. Cosine of 270. Tangent of 270. And then cosecant of 270. Secant of 270. And cotangent. Now, if we draw this picture, and we know that 270 is here, and this is the unit circle, okay? And then at the unit circle at 270, remember this is an xy where that's a radius of 1, then at 270 degrees, this point right here is 0, -1. Remember that we did the ordered pairs, right? This was 1, 0 because the radius is 1. This was 0, 1. This was -1, 0. And that point right there is 0, -1. So the x is 0. The y is -1. And the radius for all unit circles is 1. So sine for the unit circle is y, this is x, and this is y over x. Now you could say y over r, but since r is 1, it doesn't really matter when you divide by 1. So for sine, we have the y value. On a unit circle, sine is always equal to the x value at that angle. Cosine is the x value. Tangent is the slope. So if you have a slope of a line that's vertical, that's undefined. You can also say that it's y over x. And if it's y over x and you divide by 0, you can't divide by 0. Cosecant is a reciprocal of -1. So if you take -1 over 1 and you flip it over, then you have 1 over -1. It's still -1. They always have the same sign. Sine and cosecant will have the same sign. Cosine and secant will have the same sign. Now, normally we say that 0 doesn't really have a reciprocal, but let's just say that this is x, it's 0 over 1 for cosine, then the reciprocal is 1 over 0. Okay, the reciprocal, and that's undefined. So anytime you have 0, and they ask you for the reciprocal function or the reciprocal trig function, you're going to put undefined. Same thing with undefined, the reciprocal trig function, we're going to use 0. All right. So you guys try the next one. It's the same thing. We already have a picture drawn up here, so you don't even have to redraw the picture or anything. Sine, cosine, tangent of 90, cosecant, secant, and cotangent. So just so you know, if you're on one of these, the x or the y-axis, your answers are going to be 1s, -1s, 0s, or undefined. All right, so at 90 degrees, we have the point 0, 1. And the radius is always 1 in the unit circle. All right? So sine is y, cosine is x, Tangent is the slope on this line. So this is the reciprocal of sine, the reciprocal of 0, and the reciprocal of undefined. And that's it on that one. Go ahead and do these three problems. Find sine, cosine, and tangent for these. And see how you do. Do them the same way that we did before. All right, I'm going to go ahead and do this with you. So I know we don't have a lot of room. I'm going to put the answers down here. Sine, cosine, tangent, cosecant, secant, cotangent. So if we go 3, -3, hopefully you know that that's a 45, 45, 90 triangle. That's a 45-degree reference angle. X is 3, Y is 3, -3, excuse me, and then this would be 3 radical 2 if you were doing, because I don't want you to use, so this is not a unit circle, by the way. But you can divide all these by 3, and if you divide all these by 3, that'll be 1, -1, and radical 2, and that'll be the easiest way to do that. So you don't have to reduce all of these. So this is y over r, -1 over radical 2. We don't want the radical on the bottom, so -1 over radical 2, we would have to multiply top and bottom by the square root of 2, so you would get negative radical 2 over 2. Remember when we did all the 45 angles, this is 315 here, all the 45-degree reference angles on the unit circle, then all the xy's were radical 2 over 2. For cosine, it's going to be x over r. So for cosine, this is sine. For cosine, it's going to be x over r. So if you multiply by radical 2 over radical 2, you get radical 2 over 2. Remember, all the 45-degree reference angles are going to have the same answers for x and y. Tangent is the slope. So tangent is y over x. The reciprocal of -1 is -1. The reciprocal of radical 2 over 2 is just radical 2. And those are your answers for number 1. All right, so you should have done these next two problems. I'm going to go ahead and do them and then put the answers in. So we have -8, +15. All right, so x equal -8, y is equal to 15. For r, we're going to have 64 plus 225 equals r squared. 289 equals r squared. And then if you take the square root of both sides, you're going to get 17 for r. All right, so sine is y over r. So this is the reciprocal. Cosine is x over r. This is the reciprocal for secant. And for tangent, it's y over x. And this is the reciprocal. Now, you're always going to have only 2 that are positive, and the rest will be negative, unless you're in quadrant 1, and then in which, if you're in quadrant 1, then everything will be positive. All right, for the next one, -5, -12. Okay, so x, -5, y is equal to -12. You can even put 12/5 here and 5/12. Tangent will be positive. This line is sloping up. Remember, tangent is slope, and if you have 2 negatives, it's going to be a positive. For r, you're going to have 144 plus 25 equals r squared. So if you take a square root, r is equal to 13. So this is y over r. Cosine is x over r. And these are all the reciprocals, negative 13/12 and negative 13/5. All right. If we're going to do the unit circle to evaluate the 6 trig functions of 180, remember 180 is here, and that point is negative 1, 0. So sine of 180 is the y value over here, which is 0. Cosine of 180 is the x value, which is negative 1. And then tangent of 180 is the slope of this line, which is 0. Cosecant is the reciprocal of 0, which is not really the reciprocal, but we are going to write undefined. Secant of 180 is the reciprocal of negative 1, which is still negative 1. And tangent of 180 is 0, so cotangent is the reciprocal, which again, we're going to write undefined for that. All right. Next, we're going to talk about reference angles. Reference angles are very important to what we do. So for a reference angle, it's the angle that's formed by the terminal side and the x-axis. Okay, the reference angle is the terminal side and the reference angle. So when we're doing this, if you look here, let me move this over. The reference angle is, in this case, 40. It's always formed by the x-axis and the last side. Okay, so if I pass over here, then now for 320, the reference angle is 40. Okay, the reason these are important, so let's say everywhere that the reference angle is 30, at 330, then the sine value is 1/2 in every single one. So the reference angle here is 30. Sine of 30 is 1/2. So sine of 330 is also 1/2. It just happens to be negative because it's going downward. Let's look for another 30-degree reference angle right here at 210. So because it's a 30-degree reference angle, the sine value at 210 is also 1/2. Again, it's negative because it's pointing downward. Okay, at 150, reference angle is 30, so the sine value is 1/2. It's positive because it's going up, so on and so forth, okay? So the reference angle is how far away the last line is from the x-axis. All right, so what I want you to do here is find the reference angle, and I also want you to tell me what quadrant you're in, just because I think it's important for you guys to know that, okay? So negative 130 is here. And since this is 180 and we're at negative 130, the reference angle is 50 degrees. And we are in quadrant 3. Okay, so I want you to give me the reference angle and the quadrant that you're in. So go ahead and do the next one, please. It's the same exact number. I should have switched that. Let's switch that to, and on your notes, it'll already be switched. So I'm going to say positive 260 degrees. All right. So positive 260 is way over here. Okay. And that's 10, but the reference angle is actually 80 degrees. And we're in quadrant 3 still. Okay. Go ahead and do the next two. negative 220. So this is negative 180 plus another 40. So that's negative 220, and that's 40 degrees. So reference angle is 40 degrees, and we are in quadrant 2. 15 pi over 6. In this case, I would multiply 180 over pi so we can make it into degrees. That cancels. 6 goes into that 30 times. 30 times 15. What's 30 times 15? 300 and 150. So 450 degrees. So 450 degrees is, okay, that's 360 plus 90 more. So that gives you 2 1/2 pi. So 2 pi is here, and then half a pi is there. All right. All right. So no reference angle, but we are on the y-axis here. All right, let's fill these in. So these are all the 45-degree reference angles. And again, reference angle always attached to the x-axis. So like here, this is your reference angle. This one is your reference angle here, and this one is your reference angle there. So here I would like you guys to fill in each angle, just like from the unit circle that goes here. And do the same thing for all of these, okay? So these are all 30-degree reference angles. And these are all 60. So fill in the angle that goes here. And here, and here. Okay. And pause the video so you can come back and check your answers. All right, so I'm going to color code these. 30 degrees away from the x-axis, so this one would be 150. This one would be 210, and this one would be 330. For the next one, this is going to be 60 degrees, 120 degrees, 240 degrees, and 300 degrees. Okay, and the reason that these are important is because here, all the x and the y values are going to be radical 2 over 2, which are your cosine and sine values. The signs will be different depending on which quadrant you're in. For the second one, all of these are going to have the long x and the short y. So this will be cosine, this will be sine. So positive, positive, and depends on what quadrant you're in, but for all of those angles. And then for the last one, you're going to have a short x and a long y. And those will be all the answers for cosine and sine in those quadrants, depending on the angle or what quadrant you're in. Sometimes these signs will change, positive, negative, or so on and so forth. All right, so we're going to evaluate these. It says no calculators allowed, so here's what I suggest you do. So we go tangent of negative 240. So that's going to be here. So for tangent, the way I look at this is that it's slope. Okay, so that's a 60-degree reference angle, but that's a steep slope. And the steepest slope for tangent is radical 3. There's no fraction. And it's going to be negative radical 3 because it's sloping downward. Okay. For the second one, 17 pi over 6. In this case, If you want, you can change it into degree if it's easier. So the pi will cancel, 6 goes into that 30 times, and then 30 times 17 is 510 degrees. So 510 degrees is 360 minus 360. So that's 150 more, which is here. And that's a 30-degree reference angle. And since I'm looking for cosecant, I'm looking for sine. So sine will be 1/2. Sine of 17 pi over 6 is 1/2. So cosecant of 17 pi over 6 is the reciprocal of that, which is 2. Next, cotangent of negative 210. Actually, go ahead and try the next two on your own and see how you do. All right, negative 210 is here. That's a 30-degree reference angle. So tangent of negative 210 is negative, and it's the flat one, which is the fraction, which means that cotangent is the one that's not a fraction, which is that guy. And this should be negative. I don't know why the negative sign erased. Okay. Next one is cosine. So I'm going to reduce this first. So 5 pi over 2. So 5 pi over 2 is 2.5 pi. So it's 2 and 1/2. So you're right here. And so at the 90 degree, remember that point is 0, 1. So cosine of 5 pi over 2, which is the same thing as cosine of 90. I'm just go ahead and do 5 pi over 2 is the x value here, which is 0. Okay, and this is from the unit circle. You can change that into 180 divided by pi. So that goes in 90, so that's 450 degrees, which is right there. All right, I'm going to go ahead and skip example 5. All right, so let's go ahead and do 5 through 10. I want you to find the reference angle and the quadrant for these. Okay? For the ones that are in radian form, you can change them into degree and then do it that way. All right? So you're going to sketch the angle, find the reference angle, and then state what quadrant it's in. And then these, you're going to be using the unit circle. If you need to change that to a degree first, you can. All right, now that you've hopefully finished all these, I'm going to go ahead and do them. So the first one, the angle is 210, so we'll sketch that. The reference angle is 30 degrees. Remember, your angle has to have 3 arrows on it when you sketch it. The reference angle is 30 degrees, and the terminal side of that reference angle is in quadrant 3. For the second one, we have negative 260. So this is negative 180 plus another 80 degrees. So we're almost at 90. That reference angle is 80 degrees. Remember, the reference angle is from the x-axis. So reference angle, and it's in quadrant 2. For the next one, I'm going to multiply this by 180 over pi just to make it into degrees, so it makes it a little bit easier to deal with. So the pi's cancel, 9 goes into 180, 20, and then 20 times negative 7 is negative 140. So negative 140 degrees is about here. The reference angle is 40 degrees. And that reference angle is in quadrant 3. And I forgot to put the arrow at the beginning of the angle, so there you go. Next, arrow at the beginning. Going to multiply this by 180 over pi. You don't want to have both pi at the top. That's how you know. The pi cancels. 4 goes into 180. So if you don't know that, just divide by 2 twice. If I divide by 2, it's 90. And if I divide by 2 again, it's 45. You can go ahead and multiply 45 times 15 in your calculator. That'll give you 675. And then I'm going to subtract 360 from that. So that will give me 315. So that means I'm going to go around 360 and then another 315 after that. Okay, so this is 675 degrees, which is the same thing as 15 pi over 4. The reference angle is 45 degrees. Now, if they wanted you to write the reference angle in radians, you would have the reference angle as pi over 4. And then here you would have to do the same thing. So if I wanted it pi over 180, my reference angle would be 2 pi over 9. Okay, for the reference angle, you could do it that way. And this is in quadrant 4. All right, next. These will take more time, and we're going to have a lot more practice. I don't expect you to get everything right now. Cosine of negative 210. So negative 210 is here. The reference angle is 30. So if you're making this right triangle, this is on the unit circle, the 30 is. So cosine is the x value. So it's the long x, but it's negative because it's going to the left. And that's the long leg, and it's negative. For secant, I'm going to multiply this by 180 over pi, unless you remember what this is, because that's almost 2 pi. So you might already know that's going to be at anything that's a pi over 4 is going to be on the 45. And since this is 2 pi, this is just short of 2 pi. So that's going to be at the 315. So if you want to do it that way, you can. If you multiply this cancels. 4 goes into that. Remember, divide by 2 twice. And 7 times 45 is 315 degrees. So at the 45 degree reference angle, the x and the y are the same. So that means cosine of 315 is radical 2 over 2, and so is sine for that matter, but sine would be negative. But secant goes with cosine, so secant will also be positive. The reciprocal of radical 2 over 2 is just radical 2. Okay, so you can do the work for it, but just know that the reciprocal of radical 2 over 2 is 2, just like the reciprocal of radical 3 over 3 is just radical 3. Okay, and that goes for tangent and cotangent. All right, and we're not going to do that problem, and so we are done with section 8.3. We'll definitely take a lot of time practicing these problems and until you feel familiar with them.